start this then. Now what I'm showing you on this is we're doing this backwards. I'm giving you information and you're going to give me the a sine wave. So let's go through this. First of all, watch this carefully. This is something you're going to do a little bit later in the semester in a project. So we're going to do on this 16 and 17, this is what you should write down to start with, is we have this general form, y equals a sine of omega times x, okay, just that, and then like plus or minus b or something like that. So what we were kind of talking about last time is this is the amplitude. Omega is not the period, but it gives you the period. And then b is a up or down transformation. So what we're going to do on these is we're going to take the information I give you and you're going to write an equation for this now, okay? So on number 16, well, what you do on number 16 is the amplitude's 3, so that would plug in there. Now the period's 4 pi, but that's not what omega is. The way you need to approach this is like this. We have a formula, we learned this last time, and that's the period is 2 pi over omega, okay? Now I told you what the period is, so that 4 pi is going to plug in there. So what you're going to have is 4 pi equals 2 pi over omega like that, okay? Now solve that equation for omega. See, that's a simple equation. You can just cross multiply that if you want to, and then you'll get what goes in for omega, and then we'll be done. Then we'll have our answer. So I'm just going to cross multiply that. So that's going to be 4 pi omega. Okay, then go this way, that's going to be 2 pi. Okay, then you could get omega by itself, so you should just have to divide by 4 pi. So what's the right-hand side? The pi's cross out, 2/4 gives 1/2, right? Okay, so what that means is that's what omega is, so that's what's going to go there. Okay, if I give you the period, I don't give you what omega is, but I give you enough information to figure it out. Does that make any sense? Okay, you got this formula right here that you're going to use to find omega. So that means the answer to this problem is going to be y is equal to the amplitude, which is 3, and then we have the sine of omega, which is 1/2 times x, and that's it, okay? Okay, all right, any questions about that? Okay?
Yeah, I'm sorry, so he's going to multiply, and it's 4 pi omega.
No, I did is I solved that equation to get omega. So I gave you the period's 4 pi, and then we know that the period's 2 pi over omega. So I end up solving this equation by cross multiplying. Okay, you guys got that or not? Okay. All right, this next one's very similar. So we have an amplitude, and then we have the period 6, and then we have a vertical translation 7. So what you want to do on number 17 is we really know that A is 3, okay, that's the amplitude, and then B would be the up-down, so we know that B is going to be plus 7. If we're going up, we're going to add 7 like that. Then you got to just find what omega is, so it's the same idea. You have the period is equal to 2 pi over omega, okay, I give you the period is 6, so then you're going to solve that equation right there for omega, and then you'll get everything put together, okay? All right? So what we have is cross multiply, so what you're going to have is 6 omega equals 2 pi, and then we divide by 6. Okay, what does that reduce to? That looks like 2 over 6 is 1/3, so that means omega is pi over 3. Okay, like that. So what we have is these 3 pieces of information, and then we plug into this formula up here. Okay, all right, is that good with everybody? Okay. All right, so what we'd have then for our final answer to number 17 is we'd have y equals 3 as the amplitude. Then we would have sine omega, which we found to be pi over 3, times x. And then we had an up transformation, so that's plus 7. So this would be the answer to this problem right here then. Okay? So there's really nothing to that. The only work on that problem is finding out what omega is, and that comes from this formula for the period. Okay, you guys follow the algebra and everything on that, okay? Okay? Now what we're going to do now is do the same thing, but we're going to look at it graphically, and you need to pay attention to this graphing thing right here. Always test over this kind of thing, and you want to do this without a calculator. It's a little harder to take a graph and write an equation, but it's exactly the same kind of principle on this then. So I'm going to do 2 of these. Now, the way that I like to do this is number 18. You can use a sine or a cosine, okay? It can be either, but here's the way I like to look at this. Remember, when we learned the cosine started high, right? Remember, 0, 1 is a point on the cosine. The sine started at 0, 0. So for that reason, I'm going to make this into a cosine, and I'm going to make that into a sine. Ultimately, it'll work either way, but at this stage, if you see the high point at the beginning, then make that a cosine. If you see 0, 0, make that a sine. That's the idea. Okay, now on this number 18, this is what you ultimately got to look at here, is you got to know these things. You got to know what the amplitude is, okay? You also got to figure out what the period is, and you got to figure out if anything is moved up or down. That's what we've talked about so far, okay? Does anybody know what the amplitude of that graph is by looking at it out of curiosity? 5, good. Okay, the amplitude, really what we learned it is if you take the maximum as 5 and you take the minimum's -5, it's just half the distance between those points. Those things are 10 apart, right? So what you do is just half of 10, so that's going to be 5, okay? And that's the way to learn it. If this thing was adjusted up or down, then you would need to look at it that way. It's always half the distance from the max to the min, okay? Now we got to look at the period on this. Let's see how observant on this we are. So remember, we have 5 key points. I'm going to start here. To me, it's always good to just start there. That's 1, 2, 3, 4, 5 key points. Okay? You always have a high point, x-intercept, low point, another x-intercept, and a high point. That takes you through one cycle. So what is this period? What would that be? We measure the period on the x-axis. So what's that? Pi, good. Okay, so the period is going to be equal to pi. So you have to be able to observe that from the graph what the amplitude and period is. And that's not generally that hard to do. Okay, it can get a little bit more difficult once we get into learning about phase shifts and stuff. Okay, so that means the period would be pi. Now we're ready to put together our equation, and we're going to do a cosine. So with this thing, we're going to do the same formula. Period is 2 pi over omega. Plug in the period, which is pi, so that's pi equals 2 pi over omega. And then I always just do this by cross multiplying. So that's going to be pi times omega equals 2 pi. Then you can divide both sides by pi. So what's omega? 2. The pi's cross out. So we end up getting omega is equal to 2. Those are the key pieces of information we have to know. Okay? Now, if you look at this graph, does this graph look like it was shifted up or down? No. How do you know? Because the max and min are the same, right? Okay, if the max is 5 and the minimum is -5, that means it's symmetrical. If they were different, then that would mean it was moved up or down. So we don't have to worry about the up-down transformation on this. Now we're ready to write the answer. So here's how you write the answer. Okay, you would just say y equals, and the formula is a cosine omega x. So we would get the amplitude was 5. The cosine omega is 2. So that would be the answer to number 18. Okay, that's how you would get that information on that. Okay, any questions about that? Okay, amplitude, period, is all that good? Okay. All right, let's see what we got going on the next one. This is pretty similar. So what you want to do with this one is we're going to use a sine wave. So we're going to kind of look at a sine omega x and see what we get out of that then. Okay. So let's look at what the amplitude is. By looking, what's the amplitude? 3. Okay. Again, the max is 3. The minimum's -3. The distance between -3 and 3 is 6, and then half of that distance is 3. So what's going to go there is a 3 like that. Okay, I know you don't have to go through that process, but if it was moved up or down, then you would have to go through that process. It's symmetrical, so it's easy to see that amplitude's 3. Does that make sense to everybody? Okay. All right, now let's see if we can figure out what the period is. Now you can start anywhere you want to. I'm going to start over here and do my 5 key points. That would be 1, 2, 3, 4, 5. Those are my 5 key points. Okay, you always have like beginning, minimum, back there, maximum, like that. Those are the 5 key points. Okay, the period would be from here to here. What is that distance in your head? 1, because that's a half. That's another half, so that would be 1. So that means the period is going to end up being equal to 1, like that. And if you can't do that in your head, really all you do, if you can't do that in your head, you will encounter times when you can't do that in your head. You just do a half minus a half, and you make sure you get a positive answer. So all that is that's just a half plus a half, so that's a whole, isn't it? Like that, okay? So that means what we're going to have there is that's not omega, but that's enough information to find omega. So again, we go to the formula, period is 2 pi over omega, and then we can find omega from there. So the period's 1, have 2 pi over omega. Okay, I'm going to put that over 1. I'm going to cross multiply. This time you've got omega equals 2 pi. So that's what goes in there, and then you got the answer of the problem. Okay, like that. So the final solution on this one, the equation would be 3 sine of 2 pi x, like that. Okay, so that's how that goes. All right, so again, when you find omega, what do? Period equals 2 pi over omega. You can always figure the period out from the graph if you look at it the correct way. Okay, how's that look to everybody? Okay, we're going to revisit that, when we get into what's called a phase shift. And it will become a little bit harder, but in this section, it's not that